Today we will solve this question. In this question, the main motto of this question is to find the relationship between the drift velocity and electric field. As you can see, in every option there is electric field. Means it is asking the relationship between the drift velocity and electric field. The relation between the drift velocity and electric field is Vd. Drift velocity is directly proportional to electric field. Actually, Vd is equals to mobility times the electric field. By seeing this equation, we can easily eliminate one option. As Vd is directly proportional to electric field, we can easily eliminate this option because it states that it is independent of electric field. So this is option. If you know only this much, there is a chance that you can choose this option, but definitely it is wrong. We'll check the reason why. If we draw the graph between the electric field and velocity, according to this equation, if the electric field increases, the velocity also increases. So the graph should be somewhat linear. If this is true, sometime at some point of time it will cross the light velocity. That is practically not possible. So practically the velocity gets saturated after some time. So this field is called high field, and this field is called low field. Here Ohm's law is valid. Of course, this is off the topic. Here you no need to know this. So this is high field and this is low field. So what's the reason it's getting saturated is as the electric field increases, the velocity as usual increases. But because of the velocity is increasing, there will be more scattering. Because of that, there are more collisions. Because of that, the energy is lost. The energy gained from the electric field is dissipated in terms of phonons. The energy gained from the electric field is dissipated in terms of phonons. Phonons are nothing but atomic vibrations. So from this information, let's choose the appropriate option. In this, it increases at low values of electric field, okay, and decreases at the high values of electric field. I think this is wrong because it gets saturated at high values of electric field. Last option, it increases linearly with electric field at low values of electric field and gradually saturate at higher values of electric field. In this 4 option, this is the most appropriate option. This is the right answer. So this is question 2. In this question, 1 volt is applied across a semiconductor which is uniformly doped of length 1 micrometer. So it's asking the electric field at x equals to 0.5 micrometer, means at here 0.5 micrometer. So electric field E is equals to V by L. V is 1 volt by 1 micrometer. That is equals to 1 into 10 to the power of 6 volts per centimeter. So when in the question, you may think it's asking electric field at 0.5 micrometers. So you may think electric field is equals to V by L and the voltage is 1 volt by 0.5 micrometer. And the answer you will get will be definitely wrong. Because if the length is halved, the voltage will be also half. So at x equals to 0.5 micrometer V by L. The voltage we should keep is 0.5 by 0.5 micrometer. Then also we will get 1 into 10 to the power of 6 volts per centimeter. The point is we should also divide the voltage because it is uniformly doped. If the length is divided, we should also divide the voltage. Just want to add one more point in it. Why we are doing this? Because electric field is a point vector. For instance, if you take a wire, this length is L. The cross sectional is A. So R is equals to rho L by A. If the length is halved, the length becomes L by 2. Then the resistance will become R by 2. Because here resistance is a cumulative. Whereas electric field is not cumulative. It is a point vector. That is a main reason the electric field here and here is same. But whereas the resistance over here is not same. As the length increases, the resistance increases because the resistance is a cumulative thing. Rho, as we are telling rho is like point vector. Rho here along the length of the wire is same. So that's what I want to convey this from this sum.